project management, and in particular we'll be looking at two tools that can be used in help manage the project better. Okay, and let me tell you that project management is a very important topic in today's business and also has been in the past, and it's an extremely invaluable tool for people in the industry to manage large projects and other things like software development or construction of bridges, skyscrapers, or roads, talk about any other activity or new product launch or research and development projects and all. So there the project management is an invaluable tool. Okay, I mean what the things that are more important for a manager basically are to know few things before, like how long would the project take to finish, and then what are the activities that are there in the project that needs close monitoring, and what are the activities that do have some leeway in those, so that some in terms of exercising the control, you really don't have to be so much rigid over there, but there are some activities that are critical that they have to begin and finish at that given time only. Like this kind of information is very, very useful. I'll talk more about it as we go along. Okay, and so this is fairly a long topic, and just do a justice to this topic in about 2 or 3 lecture hours is not sufficient, but this course can be easily taught as an entire semester long course because there is really so much theory and there are so many tools and other things that we need to know about. But again, this Management 313, which is a quantitative methods class, or let's say a modeling class, is an introductory class. So here we want to know more and more topics, and in case if you had to use something at your work later on, you can always refer to other sources that go a little deeper into that subject matter. So here in this chapter we'll be taking a look at 2 things. One is called the PERT, PERT, that stands for Program Evaluation and Review Technique. And the other one, again, another project management tool that we would come across is a critical path method, okay, which is abbreviated in abbreviation form as CPM. Okay, but both of these tools address the same questions, for example, how long would the project take to finish? Again, look, this is a very important piece of information that one needs to know. As a manager, you want to know when would the project come to a closure. So you want to know how long it would take. Okay. On the other hand, let's say that if you are a contractor and you are entertaining a bid, okay, then again, this piece of information is important for you because this can make a difference between winning a contract or losing a contract. For example, if I am entertaining the bidding, I would be looking at the bids that I get in terms of when would this project finish. If I am a real estate developer, then it's in my interest to see, that if some other contractor or builder, quotes a smaller time frame compared to what you quote, then of course, that person definitely is in a more favorable position to win the contract than you. Of course, the cost is another consideration, reputation, and so many other things go. But one of the critical dimension is, of course, how long would the project take to finish. That's a very, very important decision that we need to know. Okay, information that we need to know. Then, now, as I said before, in order to finish the project, all the activities have to be carried out. Okay, it's not that if you leave out one activity, of course, the project is not done, but all activities have to be done. Okay, the critical activities are those activities in terms of not delaying the project time further. Okay, in that sense, they are critical to finish the project on time. Okay, so that is those activities are critical activities. Then, of course, we would like to know how much is it going to cost. Okay, this project, but you as a contractor, so you have to have the information about it because you want to build that thing into your quote. Okay, then can we shorten the project completion time? Meaning, suppose if you come up with a bid and if I think it's too long, then you would like to know, of course, if you can commit more resources to do a thing, then naturally the amount of time that you spend on a particular activity can be shortened because you are committing more resources. But on the other hand, when you commit more resources, it's going to cost you also. So now is it worth it? The benefit that you get should outweigh the cost. So this is what we mean by, can we shorten the project completion time? That is called the project crashing. Then if that's the case, how much would it cost? Okay. And then another thing is, how can we protect ourselves from litigations? Okay. Now in any, let's say in terms of real estate, okay, commercial real estate. So if I am a builder, let's say if I am a commercial real estate developer, then it's in my interest to have the building done sooner and have the merchants and other retailers kind of locate in there, because that's how soon I can start earning my revenue. Okay. Now, if you are not going to finish your project and if you delay, that's not my fault, that's your fault. So why should I be penalized for that? So naturally I would ask for, in the clause, the penalties. Okay. If you don't finish the project, let's say in 6 months, if we had to go beyond 1 more month, then there should be some sort of a penalty. Otherwise, what is the incentive for you in not pushing the completion time later? Okay, so there is not. So the incentive for you would be to avoid the penalty. So for me, as a developer, that's an insurance for me, because I know that you as a contractor would be able to finish, or would try your best to finish your project on time. Okay, so that's what I mean by here. How can we protect ourselves from litigations? Meaning that if you don't finish it, then I might take you to the court if you don't pay the penalty. But on the other hand, it's in your interest to win the contract, at the same time minimize the penalties that you would be required to pay. Okay, at least you should know beforehand what is the probability that such a thing might happen. Okay, so that's what I mean by over here. More about it as we go along in our lecture. Now let's look at the main difference between the PERT and CPM. See, under PERT, the activity times are probabilistic. Okay, what I mean by this is this. Let's say that you want to build a home. To build a home, you have to survey the site, lay the foundation, then put the structure, then you have to go through several different activities. Okay, let's take one particular activity. Let's say that you are a developer, and in this development that you are developing, which is a residential development, let's say you have 5 plans to choose from. Let's say if you have about 100 houses and an average about 20 houses on each plan, if you have 5 plans. So these 20 houses, okay, let's say the basic design is the same, the layout is the same, right, of the house. Okay, so the foundation would be same. Now this activity on house number 1 may take you about 2 days, on house number 2 may take you about 2.5 days, on house number 3 it may take you about 1.75 days, etc. So here the same activity, when being repeated many times over, okay, it takes each time a different amount of time. Just like the way that it would take you not exactly the same time to travel from your home to workplace or to the university every day, and you take the same route. Okay, so each activity time is a variable. That is the reality. Everything, all activity times are variable. Okay, then if you do this quite number of times the same activity, if you time yourself and record how long it took you to do that same activity, okay, so this is the kind of a curve that it would follow. Okay, so this has been tested in reality and found to be true. So A stands for the optimistic time, meaning that you are able to lay the foundation in 1 day, and probability here means those instances are very, very few. Okay, so again, the chances that it would take you 1 day next time is remote or very small. So most likely it took you about 2 days, so this is where mostly it is going to be. But on the other hand, there could be occasions in which it took you much longer than that. So just like Murphy's Law, like everything that we thought would go wrong, has gone wrong, So many times we do face that too. Gosh, what did I do? I mean, everything that I seem to have today, do today, is just going wrong. So of course, those things happen. Okay, so here it could have taken you about 4 days to lay the same foundation, but again, those occurrences are very, very few. So hence the probability is very low. Okay, so when you build around that, for the next time around, what time would I use in my project? So what you had to do then is you had to use the average time, which for this sort of a distribution is given as the optimistic time plus 4 times the most likely time plus the pessimistic time. Now divide that sum by 6. So that is the average time for this sort of a distribution. And you have to compute the variance also in each activity, because each activity takes a different amount of time each time that you do it. So hence there is a variance and a standard deviation present in this activity durations. Okay, that variance is given as the difference between the pessimistic time and the optimistic time. Divide that by 6 and square that result. Okay, so when you use these average activity times in computing the project time, what you get at the end after you have finished the project, or at least the estimation, what you get is the project finish time as an expected finish time. In other words, there is always a likelihood that you could be done with this project before this time, or it can take longer than that. So on an average, this is what it should take you. Okay. On the other hand, the activity times that are considered under CPM, critical path method, are all constant. If it takes you 2 days, it's going to take you 2 days, no more, no less, no matter when you do it. This could be your first time or second time or 10th time around. It would take you exactly the same time. So the project time in that case is a deterministic. Okay. Now the question is that all activity times, that anything that we do ourselves on a repeated basis, every time it takes a different amount of time, then where is the place for this deterministic thing in this sort of a realistic situation? Okay, consider a situation like this. Okay, so both of them are at work at the same time. Let's say that you are a big contractor. Okay, big contractor. You don't do each and every activity yourself. What you do is you sub out your work to other people, like plumbing, electricity and foundation or framing or painting. You sub them out. Okay. Now, if you have to finish the house in about 3 months, there could be a person, who could be doing the drywall. Okay. Now, let's say John is the contractor for drywalling your house that you are building. You would give John 1 week time to drywall the whole house. Okay. Then, let's say, that Kyle is the subcontractor for doing the painting. Okay, so you schedule Kyle to come a week later. So next Monday morning, 8 o'clock, Kyle would be there with his crew. So you tell John that he has 1 week to finish the drywall, and he has to be out with his crew come next Monday morning. That's when Kyle would come in with his crew. So now for you, okay, for you it is a CPM. So when you tell me that I'm your customer, that the house would be done in 3 months, so this is how you would have scheduled 1 week for John and 1 week for Kyle. Okay, so then it is CPM for you. But when it comes to John, so who has to do the drywall and drywalling the house in 1 week, he could be done in 5 days, he could be out, or he could be there on Sunday midnight still finishing it up. It's up to him how long it's going to take. But for you, he has to be out by Monday morning 8 o'clock. Okay, so then he would think about, okay, let me put some more people on drywalling the house so that he would be out by that time period. So for him it's a PERT, for you it is a CPM. So they are at work at the same time. Okay, now let's look at some of the common things between these two before we start to solve a problem. Okay, there are certain things that are common between the PERT and CPM when you analyze a project. In case of PERT, since each activity times are variable, you are given 3 time estimates: optimistic, most likely, and pessimistic. When given that, for each activity you have to find the average time using the formula that I spoke about before, and also compute the variance in those activities. Keep a record of that. Okay. Then in this area, both PERT and CPM, you would do the same analysis for both. The first one is to draw the network. In other words, like the example of building a house, there are a few things that you have to do before some other thing can be done. Like, for example, you have to drywall and finish that wall before you can start to paint. You cannot paint and put the drywall. So there is that requirement that needs to be done. One needs to be done before the other thing can start. So that is a precedence relationship. Okay, you can take those things and represent that on a graph. Okay, so that is that network. We will look into a network very soon. Then once you have that, then on that network, put the average time, how long it would take to finish each activity. Then start analyzing. So these are the things that you do: early start and early finish time for each activity, as well as late start and late finish time for each activity. Then once we do that, we can identify the critical activities and also the non-critical activities that have slack in them. So now, critical activities need close monitoring, okay, so that these activities have to start and finish in that time, given time itself. But for us non-critical activities, there is some leeway, there is some flexibility. It can start today or it can start 2 days later also. So we have that flexibility to move them back and forth, which is very important for a manager. One thing is that by exercising this good control, not only it would help you exercise a good control, you would not also lose the focus. In other words, if you have too many activities going on at the same time, you have many people working on that. So in that sense, you as a manager would lose focus and also would lose your supervision. So the inefficiencies would creep into the system. Now, if you know what are the non-critical activities and then how much slack or leeway or flexibility you have in them in scheduling little later, now the work area could be less congested, and now you can have a better control. And not only that, since this activity started late, and hence the payment that you make on those activities also could be late. Okay, which is very, very, very important, because each project is a multi-million-dollar project that usually goes on. Okay, if that is the case, then I would rather have about $500,000 sitting in my bank account and earn the interest on that, rather than to have this activity scheduled earlier and pay it out to the person who did it. Okay, so now that person would have that. See, now I could use that time and I can earn money on that. Okay, so that's why it is important to know what are the non-critical activities. So we would know the project time. In case of CPM, okay, so we would know the time that we get is deterministic, but in terms of PERT, we use the average time. So hence, the project time that we get is an expected time. So if it is a PERT problem, then remember, it is an expected project completion time. So there is always a likelihood that it may get delayed. It may take longer than that. So here we want to compute the probability that it would be finished in a given amount of time. Okay, so this would help you in terms of protecting yourself from paying any penalties or any other thing. Okay, let's look at problem